Welcome everyone to Algebra 2, Section 6.5, Graphing Polynomial Functions. This is the very last part of Algebra 2, Chapter 6, which is over polynomial functions. So, how do we graph polynomials with a degree greater than 2? Basically, not just linear, not just quadratic, not just constant functions, but beyond that. So our cubics, quartics, quintics, so on and so forth. So, some things you want to look for are local minima, which are the minimum point or points of the graph. Now, how that differs from just minimum in general, a minimum point, is that there might not be a lowest singular point, and the reason we say local instead of just, minimum in general, and it's minima is plural, is local means that, hey, sometimes it's not actually the lowest in general, it's just the lowest that we kind of see between a certain set of points. And the same thing's true about the local maxima. It is the maximum, let's try rewriting that, the maximum point or points of the graph. So once again, these would be the highest ones, and not just necessarily in general, but between certain ranges. Zeros are the x-intercepts, where the graph crosses the x-axis. That's not new to us, though how we find it might be, or will be, I should say. So we're going to graph these functions. We're going to do 3 of them today. And we're going to use our calculator to find the relative or local minimum and maximum values, aka the local maxima and minima. Use the table function to find other 6 points such as x-intercepts. And I'm going to teach actually another method rather than the table, which can be more effective than the table. And helpful graphing hints. Zoom number 6. So if you hit the zoom button at the very top middle of your calculator using the TI-84 or Calc-84, zoom button's on the screen once you're graphing, and then go to option 6. It allows you to get a good view of your graph typically. And then if you hit the trace button, which is next to the zoom button on the TI-84 calculators, then you can enter whatever number in you want for your x values, or just scroll along the graph using the arrows on the calculator at the top right in order to figure out where you're going. And then the second graph button gives you the table. So if you go to graph, the far top right button, second before that, you get the table. All right, now you notice that this first one is not in standard form because the leading coefficient's really -1 because the highest exponent's 4, but we see 2x squared first. And you know what? That's actually okay for what we're going to do because we're going to type it into our calculator. And our calculator, it doesn't really matter whether we put it in standard form or not. It still reads it just fine. Whereas for a lot of other things we do, if we're doing this by hand, we'd really want to put it in standard form. So what I'm going to do is I'm going to go over to Calc-84, the app, and I'm going to go into y equals, and you'll see that I actually already have, oops, I actually hit the second button there. Let me get out of that, and then go to y equals again. There we go. So you see I already have that first function typed in, and I have this toggled on, so the graph will show. And I go to graph, and we see that this is what the graph would look like. And if you're following along with your calculator, which I hope you are doing, or you're following along with Calc-84 on an iPad, then you would see this. And ways you navigate around it is you use one finger to move around. You can use two to try and zoom in and out, but it gets really wonky, as you can see. So a good way to do it is just hit zoom standard, and if you want to zoom in, hit the zoom in button, and if you want to zoom out, hit the zoom out button, and use that one finger to drag it around. And then these tools down here, automatically clicked, are going to be very helpful for us. So one, for example, would be trace. So trace, you can, this will follow your finger, the little crosshair there. And as you notice though, even though my finger and the crosshair aren't on the graph right now, it's still moving it along the graph. And on the far left side of the screen, we see the x and y values there. You can ignore the dy/dx thing and the d squared y/d squared x thing as well. We are not going to be using those. Those are calculus concepts. So what I'm going to talk about here, though, is the local maximum and local minima. So local maxima are not going to be, let me zoom out here to show, are not going to be what we see down here on this part of the graph, the minimums, and down here. Because there's really no minimum on this graph, it goes down forever. So we're going to say the local minima is say, hey, for the part of the graph that we do see, a lot of change happening right in here, what is the lowest point we see between two other higher points? So where's the part where it goes up and then back down? And it'd be right in here. And so we try and find the lowest spot we can there. And how you'd be doing on a calculator is you'd be hitting that trace button after it's graphed and then moving your arrows left and right until you kind of find the lowest point you can find for the y value. So as we look around here, I'm trying to find my lowest point. It looks like I'm kind of getting 4.5, 4.55555 is kind of the lowest one. We see the x value is negative 0.45444. And I'm not going to make it so we have to be incredibly precise as far as rounding goes, because sometimes we can get slight errors in it. I'm going to put local minimum or minima as -4 point, I think it was, let me remember here, or excuse me, -0.4, I should say, and y, or -0.45, I should say, and the y value as 4.56. So -0.45 and the y value as 4.56. And we go to graph it, -0.45, I keep misspeaking there, would be slightly less than -0.5. And 4.56 is about 4.5 up. So we had to go to graph that about half left and 4.5 up. And be around there. Now let's go to local maximums. And even though it has a true maximum, and when I'm in trace, I can't drag out the graph along. I'll turn trace back on now. Even though we have a true maximum up here, these are both considered local maximums because we see a highest over here and another highest over here after it ducked down. So we'll call them both local maximums. So one I have about here, it's about -1.24, comma 5.14. So -1.24, comma 5.14. And I'm going to try and graph that. That's not going to be very precise, but that's okay. We don't have to be perfect on these. These are just sketches of the graph, okay? So I'm going to get as close as we can with the point values for the numbers, but the actual graph don't have to be perfect. Be around there or so. And the other local maxima would be up here, which would be the genuine maximum of the graph, which looks to be around 0.92 if you round, and 7.04 if you round. So 0.92 and 7. I believe it was, I moved it on accident. 7.04 was, I saw. And so go and graph that as well. So it'll be right up there. And so we know it's going to kind of connect between those like that, but I'll draw that in later. Now, good thing for us to find are the zeros. So a couple of ways to find it. One is to try and use the table. So I hit the table button, or on the TI-84 you hit second and then graph to get the table up in the top right corner. And you try and scroll along to find it, but you want to see where the second column here would be 0. And we're noticing we aren't actually going to find it because it doesn't pop up at a perfect point. We can see where it kind of dances around between the negatives and the positives. So a good way to do it is on the T84 is if you have the graph currently up and you hit second trace, which gets you to calc, you'll see the second option is 0. So you can scroll down and hit enter or hit number 2 on the number key, and you'll get 0. And then you have a chance to put in the left side of the graph and the right side of the graph just using your arrows. So go somewhere on the left, hit enter, go somewhere on the right, hit enter, and then just hit enter again for your guess because you don't really need a guess. And it'll tell you exactly where the 0 is. How you do it on, this Calc 84 is you actually just hit the root button. If you just hit the root button, it tells you those roots. So you can see here that the zeros end up being 1.7. I'm going to do that in orange as well. 1.7 comma, I think I wrote that wrong. 1.745, I misread where my comma was, I'm sorry, comma 0, and negative 2.066, I keep misspeaking, comma 0. And we'll go ahead and just kind of graph those roughly. Doesn't have to be perfect. So around there and around there. And you can also make a table, and one way you can make a table is by going into second trace to go into calc on the TI-84, or going to just hit the calc button here, and it says value, and go to value for TI-84 as well. And when you hit enter for that, and you're in the value option, either screen, either the Calc 84 or the actual TI-84 calculator, and you put whatever number you have. So let's say we put, I don't know, -2, and we hit enter. It shows us, hey, the y value there is 1. Okay, if we were to hit -3 or something like that, really whatever we wanted, we'd end up seeing, okay, the y value there, I must have misplaced, I did maybe 2 negatives, was that it? There we go. We end up getting a y value of -37. We're going to have a hard time graphing that. So if you fill in a whole table, for example, if I were to do -2, -1, 0, 1, and 2, using that same exact method I was just showing, we would get 1, 5, 5, 7, and -7. And realistically, the points we already have on the graph are enough to give us a good sketch. Knowing, hey, it's going to go down here, and it's going to go up, hit that local maxima, local minima, back up to the other local maxima, and back down through this x-intercept. And as you can see there, the end of my graph got a little curvy. That's okay. It doesn't have to be perfect. And you could have used those other table values to help you be a little more precise in your graphing if you would like. Let's go ahead and go on to the next one here. So on this one, we're going to do the same exact thing. So go ahead and type this function in your calculator and try and do everything you can. All right, so I have this function typed into my calculator. So if I exit out of the graph, there might be an ad. Yep, there is an ad. Turn off the sound, nobody needs to hear that. Skip the video, there we go. And I go into my y equals, I already have that one in. I just have to switch it to where that graph is showing. And now I hit graph on this one. And I'm going to zoom out a little bit more and drag it. There we go. So now I have my zoom where I want it for me, for what I'm seeing. And now I'm going to look at the local minimum or minimums, potentially, and local maximum or maximums. And this time there's really just one minimum, one maximum, and it is right here where we see it to be, about, depending on what you round to, let's say you round to the 10th, let's say 100th, either way, doesn't matter. If I round to the 100th, it'd be 0.24, and, or excuse me, 0.24, comma, -8.24. And we can go and graph that. Maybe right around there. Not perfect, but it's close. And local maximums, maxima, and this time just one of them. We end up getting about -2.89 and 7.05. Go and graph those. And it'd be around there. Once again, not perfect. Excuse me, it'd be a little farther over, about there. And then the zeros, we'd want to just hit root on this, or on your actual TI-84, you go into second trace, get in calc, and then hit the zeros and do the left and the right and all that. So we see our three zeros are at -4, -4, comma 0. Don't need the zoom. -1.414 if you want to not round until later. And then the positive version of that, positive 1.414, comma 0. And we can go ahead and graph those. So -4 is just right on a nice little point there. And the other ones are not perfect, but that's okay. And even now, we already have enough to really kind of show where this graph goes. It's going to go up here, connect, hit the local maxima, back down through the x-intercept, down to the local minima, and back up. And it's going to go up forever, and on the left side, it goes down forever. And if you want to do the table by entering in values or looking at the actual table, you definitely can. I'm not going to require it here, but I will say if I were to have done the same 5 values as last time, -2, -1, 0, 1, and 2, I would have gotten 4, 4, -3, -8, -5, and 12. Last but not least, example 3. I do still need to type this one into my calculator. So go ahead and feel free to pause and work on the video as you're trying to, as you're waiting for me to do this anyway. As you're typing this one in, you will notice that this one is, in fact, in standard form this time. All right, so now I have this one graphed, and I'm going to do the local minimums. There's going to be 2 of them, and the 1 local maxima. So the 2 local minima, you see it right around there, but not perfect. -0.59, comma, -8.71. So -0.59, comma, -8.70 or 71, I think it was. That's one of them. I'll go ahead and do the other, which was over here. And it's approximately 2.98 and -2.01. Go ahead and graph those. And be around there-ish for one of them. The other one would be about there. And then our local maximum is up here. And we get 1.41 and 5. So go ahead and graph that. Be about there. And then we want the zeros. So once again on the TI-84, you want to use the second trace again to calc and then hit the 0 option and go from there. Here I can just hit root and get the 3 numbers. And, or excuse me, 4 numbers, and I spoke. I just need to zoom in order to actually see the 4 different numbers because it's not wanting to show me. I think it's going to make me click on that one. It's odd that it's not showing me. Maybe if I turn off trace and I tap it, it'll let me see it. No, it's still not. There we go. I had to zoom in a little bit more. Got -1.2706. which you could call just negative 1.3 if you want. Nothing wrong with that. 0.4808. I'm going to round that a little bit, but you could round it much earlier to 0.48. 2.456. I'm going to round a little bit, but you can always round it earlier, like I'm saying. And last but not least, 3.33866. I'm going to round there. I guess I rounded that one earlier than the others. There you go. And as we go to graph that, graph these four, you end up getting about here, here, and here. Once again, not perfect, doesn't need to be, and you could use a table to help you with points. And we know we're going to be connecting them left to right. And so we just walk through it, and it's kind of like a connect the dots, just with a little more curves and lines. It goes back up and goes back up. And I'm not going to do the table as far as entering everything in, but if I would have gotten for the same 5 values, which you could use different values if you'd like, 43, negative 6, negative 5, 4, and 3. All right, that is all for today's lesson in section 6.5. Once again, this finishes up chapter 6.